So we're going to be creating this little graphic here using step and smooth step and mix. I did 2 videos on those. I'm on step and mix. If you don't know what I'm talking about, I'll have links in the description below or cards on the top right. So we're just combining basically what I've learned with step and mix, and we're going to make this little animation where the blinds open and close, and then we have this flashing siren stuff in the background. Let's begin. So I have a basic fragment shader up and running. If you want to know how to do that, I'll have a link in the description below or a card on the top right. So what do I have here? I have some defined constants. I have pi, which we're going to use. It helps us rotate the canvas. When we get there, I'll tell you why and where we're doing it. I have some colors here, and all of these defined just so I don't have to repeat myself in the main body of our function. I then have the U resolution, which helps us normalize the coordinates. U time, which is a variable that it's a counter, so it goes up by, I don't know what it does, just it's a linear counter that keeps on going up, a fluctuating number, so that we can use it to animate our canvas. Again, when I use it, you'll see why. I then have a function which rotates the canvas. This is a basic 2x2 rotation matrix. So you give it an angle, it rotates that angle in 2D space. We're going to multiply that by a coordinate in our space, and that's going to help us rotate the canvas. Again, when we get there, I'll tell you why. And then we have the void main function. We have the normalized pixel, or the coordinate of the pixel running the shader. And then we have the global frag color. I've set to white. So it's rasterizing white right now. We could easily do, I don't know, red, green, but we're just going to do neutral white like that. All right, so in this, we're going to be using mix and step. If you don't know what those two are, I'll have links in the description below. So we're going to start with stepping. And we're going to use step to draw a horizontal black bar on our canvas. And this is going to be a blind, and then we're going to extrapolate that to a function, and we're going to use that function to draw multiple blinds. So how do we start? How do we think about this? Well, let's start visually. What do we want visually to happen? Well, we want a black bar on our canvas. So we want it to look like this. Wherever that black bar is, doesn't really matter, but we want a black bar on our canvas. So that's visually what we want. Now let's describe this mathematically. Let's describe in numbers first. And so in terms of numbers, what is white? Well, it's 1. So that's 1 and that's 1. What is this dead space? What is black in terms of numbers? Well, that's 0. So this is what we want visually, and this is what we want numerically. We want 1, 0, 1, this relationship here. Now, how are we going to get that using step? Well, what happens if we take the difference between 2 steps? So what happens if we take the difference between this? If you don't know what step is, you give it some sort of edge case, and anything below and including that edge case, it spits out a 0. Anything above that, it spits out a 1. So what happens if we take the difference between 2 steps, or 2-step calculations like this? So 2 different edge cases, and this is 0 and this is 1. What would the difference be? What would the third canvas look like? Well, let's do the math. And so all of this is 1, all this is 1, and then all this stuff is blue, or 0. So what happens if we take all of this 1 and we subtract all of this 1? What do we get? What's the difference? Well, 1 minus 1 is 0. All right, we're still at 1 here. What's all of this 1 minus? But now this stuff is 0. It's blue. I'll just make it blue right like this. So what's all of this 1? Get back to red. Minus 0. Well, 1 minus 0 is 1. And then finally we have the leftover. We have the blue minus the blue, which is 0 minus the 0. 0 minus 0 is 0. And so we have something that kind of looks like what we want. We want a 1, 0, 1 relationship right here. Not there. Right here. A 1, 0, 1 relationship. But we got a 0, 1, 0 relationship. So how do we flip a 0 to a 1 and a 1 to a 0? A bit of algebra. So what we do to the 0, we have to do the 1. So what is 0 minus 1? Well, it's negative 1. How do we get that to be a positive 1? We can multiply by negative 1. So we've just flipped a 0 to be a 1. Let's do the exact same thing to a 1. What is 1 minus 1? Well, it's 0. What's 0 times negative 1? Well, it's still 0. So we've just flipped a 1 to a 0. So after doing all of these calculations where we take this first step and we subtract this second So we take this first step case, we subtract the second step case, we get a 0, 1, 0 relationship, and then we apply our little algebra here, which is -1, and then multiplying by -1. We should finally get something that looks like, let's be a bit cleaner with that. That's something that looks like our 1, 0, 1 relationship. So let's go ahead and do that in the code. Before we do that, let's determine the edge cases. So we're gonna provide some sort of edge case for this guy right here. So that's the first edge of our first step calculation. What is this edge right here? Well, what is this edge in relation to this edge down here? Well, it's the first edge case plus some sort of width, right? So this is what our second edge case is going to be. It's going to be the initial edge case here plus some sort of width. Let's just go ahead and start coding. All right, so I'm going to say, and I'll put it in a separate variable so we can modify it if we want to. So float blind width, it's too large, let's shrink just a bit. There we go. Float blind width is equal to 0.10 for now. And then we're going to set up our steps, our blind. We'll say blind 0 is equal to, the first step was an edge case. I'm just going to say 0.2, and then we're going to seed in with the y. So it's a bit counterintuitive, but because we're seeding in, or we're evaluating the y-axis, the up and down axes, it's going to give us a horizontal black bar. If we were evaluating the x-axis, it would actually give us a vertical bar, but we don't want that, so we have to seed with the y-axis. That's our first step, and we're going to take away the second step. And the second step, the edge case was, we'll start with the first one started, and then we're going to add the blind width. Blind width like that. And we're going to seed in with the y as well. And let's see what we get. Let's add that to the canvas right here. Blind 0. And we have our 0, 1, 0 relation. This white bar. We now need to flip the zeros to ones and the ones to zeros. So we need to subtract 1, and then we multiply that whole thing by -1. -1.0. Excuse me. Yeah, we multiply by -1. There we go. So we just created our first black bar, our first blind. Let's create a function that does this kind of thing for us. So we're just going to say, not function, we'll say float. And we'll call it create blind, like this. 3 arguments. We're just going to do a starting position for the blind. And then we're going to say, let's say blind width. And then we'll say a direction for the blind. All right. And we're just going to return this line. There we go. We don't need any of this. We need to return all this. And we need to modify. So the first step, I need you to start at the starting position that we give you. And I need you to go in the direction that we give you. And the second step, I need you to start at the starting position we give you plus the blind width, perfect. And I need you to evaluate in the direction of the direction we give you. Now let's use this right here. So float blind 0 is equal to create that blind. And starting position, I'll just say start at 0. Blind width is going to be the blind width. And the direction is just going to be the y-axis. And we have our blind down here on the bottom, starting at 0. So what I'm going to do is, I think I've copied, did I copy paste this? I think I did. It's right here. Perfect. So I don't need to do a weird transition. So I'm just going to create a bunch of blinds on the screen like this. And we're going to modify this, and I'll explain the code in a bit. Blinds. Modulated, modulated. This modulated shouldn't be modulated. Let's go with, show from command line, that was 32 to 52. 32 to 52. Replace all instances of modulated blind width with just blind width. There we go. All right, so all I did was I called this create blind function. How many times? That's 10, 19 times. It's filling up the canvas on the right because the blind width is 0.10, so it's overlapping. So just for now, I'm going to create a 0.01 blind width so we can see what we're working with. So I just created called this create blind function multiple times in 0.0, so 500th increments. So 0.0, then 0.05, then 10, 15, 20, all the way up to 95. And then I created a blinds variable here. It's a vector 3. which captures all of the white canvas, and then we're adding all the blinds to it. And I just extrapolated it into a separate variable because if I wrote all this stuff here, this white times blind 0 through blind 19, all in here, and then I added all of the other stuff we're going to add, is just going to be really, really messy. So this is a lot easier to read. So this line 59 just reads like, on our canvas, show me the blinds. So what we're going to do now is we're going to add the left curtain and the windowsill. Let's do that because we're still on the step function. So let's just say the left curtain, and it's going to be equal to a step. Let's say 0.2. See how that looks. And we're going to seed in. We want a vertical bar, so we have to seed in a horizontal value. And then we're just going to say the windowsill, which I'll just call the horizon. This is going to be, let's say 0.2. We'll see how that looks. And we want a horizontal bar, so we're going to seed in a vertical value. Let's add that to the canvas. Again, this is why I extrapolated all of this code out into one variable, so we can read it easily. So give me the blinds, give me the left curtain, and then give me the horizon. There we go. So we have the basic geometry of this little graphic all set up. What do we want to work on next? How about we add color? Let's add the lights, the background lights. Not animated yet, just the white to blue. So we're going to be using mix. So let's do that here. That's going to be a vector 3. I'm just going to call it lights like this. It's going to be a mix. Let's mix white and blue. So we're going to start white at the bottom, and then we're going to have a blue sky on top, and we're going to mix it using a linear function like this. Now let's add that to our little canvas. So give me the blinds, give me the left curtain, give me the horizon, then just give me the lights. There we go. All right. So we have our lights added. What do we need to do to finish this guy up? So 3 things we need to do. We need to animate the lights, we need to animate the blinds, and then we need to smooth out these lines so it doesn't look so crass, so crude. So let's start with animating the background first. So what do we want to do with the background? Well, we want to add some red in, right? To create that like police siren effect. So we'll do it right here. We're going to say lights is going to be equal to a mix. So take the initial white and blue background, which is the lights, add red. How do we want to add it? Let's add it the same way, linearly. So we have this little change here. Now, what's wrong with this is we want a blue top, not a red top. And it's red top because the red is the final value. It's the 1 value. So as the y right here, this y-axis, it goes from 0 to 1 up top. As it reaches more and more 1 up top, it reaches more and more red. We want the red to start at the bottom. So all we have to do is flip or invert these values with this. So we're just going to say instead of the line going up, we just want to take the inverse of the line going down or starting at the bottom. So we have the red starting at the bottom and maintain the blue at the top. So let's animate this. We want this to flicker on and off. And in order to do that, we're going to use a sinusoidal function. Let's go to Desmos. And why a sinusoidal function? Because a sinusoidal function, it goes between 2 values, the same values, on and off. So simultaneously forever and ever and ever and ever. So let's say f of x is equal to sine of x. And so the property of a sine or sinusoidal function is that it goes between, this one is -1. The default sinusoidal function is -1 to +1, -1 to forever and ever. So we can use the property of this to create a sort of like an on and off switch, because we're going to alternate between 2 different mixes, different backgrounds. So we're going to have this is going to be our off. That's our on, off, on. Except we're going to use the sinusoidal function to do it really quickly to create that flashing effect. So we're going to strip off. Should we strip off the? Actually, no. We're just going to try this. So we're going to say. So right now it's on. How do we get it to off? We're going to say sine of. We're going to take that u time, which animates a value. It's a fluctuating value. And so it's going to let us actually move through the sine curve. And you're going to, let me take the horizon off so you can see what we're doing here. Horizon, take off. There. So as you can see, it's going from -1 to +1. So it's going from that white and blue background to the red, sort of purplish to the blue. And it's going slowly because of the period of our graph, the time it takes to get from -1 down here to positive 1 is this one cycle, which is 2 pi, which is the circumference of a circle. So what we need to do to speed up, to create that flicker effect, is we need to get from -1 to positive 1 really quickly. So we need to shorten the period of this graph so we can speed it up like this. So now we zoom in a bit. We get from -1 on the bottom, which you can't see. There we go. From -1 to positive 1 up here, a lot quicker than the before. So let's just speed up the period of this graph. Right here, U time, we'll just say 20.0 times. We should get a flickering effect. There we go. So we have a nice flicker effect, a bit too fast. Let's try 10. What does 10 look like? Let's put our horizon back on. Let's see what that looks like. Times the horizon. Let's go back to 20, see what that looks like. That looks a lot better. All right, so that's our lights animated. Let's turn that off. It's giving me a headache. And we're going to move on to animating our blinds. So we're going to do the exact same thinking behind it. We have an off state and non-state. We have a look we want, and then a look we want to get to, and then we want to go back to the look we wanted initially. So let's draw it first. Let's go back here. So what do we want to animate? Just like our sky went from white-blue to the red purple blue, we have two states of our blind. We want it to be fully closed like this, and then we want it to be fully open but not zero, because if our blind was 0, there'd be no horizontal line. We'd lose it and it just look weird. So we want fully open or fully closed like this, the full width of our blind, and then we want slightly above fully closed so we can hold on to some sort of black bar like this. So these are going to be the two values we're going to alternate between. And again, just like we use the sine function because it alternates, we're going to use the sine function here to alternate between these two states. So let's do that. So let's do this guy right here. Let's say modulated blind width. And modulated blind width, I'm just going to put here. Let's do that. Let's go animated values. Let's go float modulated blind width. And we're just going to start with the normal vanilla sine. And so what this is saying, you saw a glimpse of it. What this is saying to our blind is, can I move over? Let's zoom out just a bit. There we go. What this is saying to our blind is the width, because we're tailoring or tying the output of a sine function to the width of the blind. We're saying is the blind is going to start at -1. So let's say we had, I don't know, let's say -1 here. We had 0 here. Can't see it there. Let's say -1 here, 0 here, 1 here. So the blind width is going to start at -1. It's going to increase to 0, and it's going to increase to 1. So we're going to get this weird effect that we're going to solve in a bit. As you can see, it's going from -1, which is off the screen, and then it's going to full 1 here. Why it looks like this is because we don't want it to go full 1 and we don't want it to go past its 0. We need to cut off the sine graph. We just want it to go from its 0, or slightly above 0 so it doesn't disappear, to its full width, and then come back to 0, to its full width, 0, full width. So we need to modify this sine graph. So currently what we have is something like this, right? Where this is -1, this is +1. We want the maximum, the apex, the height of this curve to not be 1, to be the width of a blind, and the current width of a blind is 0.05. So it's in 0.05 increments. So we need to shrink the amplitude of this graph to 0.05, not 1. And we need to cut off all of the negative values. We don't want anything past 0. So we need to take off all of these values here. So what does that look like mathematically? Well, how should I say this? Let's do this. How do we cut off all negative values of a function? Well, we take the absolute. So the absolute of any sort of function, of any number, just gives you the positive version of that number. So right there, we no longer go past 0. So what does that look like when we incorporate it into our little graph, our little graphic here? And semicolon. So now you can see we're never going past 0. Coming back down and never going. So that's 1/2 of our little problem solved. Now we need to solve the problem of the top. The maximum of this curve is 1. We need it to be the blind width, and the blind width is like 0.05. So to do that, we can modify the amplitude of a sine graph. So we'll just do 0.05 like that. You can't see it because it's really subtle, but now we're moving between a 0 right here on the bottom and a max and apex of like 0.5 right there. So let's do that in the back end and right here, modulating or modifying the amplitude of our graph, 0.5 times. There we go. So as you can see, we have our little blind moving from 0 to a maximum of 0.05. Now, what are we going to do here? Let's apply this animation to all of the blinds. So I'm just going to do let's do a vim command. So it starts at line 41. We'll go to line 61. So line 41 to 61. 41 to 61, replace all occurrences of blind with modulated blind width. There we go. And we have an error because this one did a double modulated. So delete this part. Are they all animating? There we go. So we have all of our blinds animating. Some problems, 2 problems with this. Number one, it's animating upside down. So we have to flip the canvas. Right now it's going from starts at the bottom and it closes at the top. We need to reverse that relationship. And also it's not staying closed long enough. So let's tackle the last part, the latter one. So how do we get the blinds to stay closed longer? Well, we could do like a whole roundabout way of creating a function that does that, but we're just going to kind of trick the end user into visually thinking that the blind is closing for longer. So what we're going to do is currently we have our blind maximum. Let's get black on that. Our blind maximum is 0.05, and so our blind minimum is 0. We get to a 0.05 and we immediately shoot back down to 0. What we're going to do is we're going to increase this maximum to like, I don't know, maybe 0.10. It's going to overshoot the maximum, but we're not going to see it because the whole canvas is going to go black. And so the time it takes it to go from this new maximum of 0.10 to come back down, this duration here, it's going to look like it's hanging closed. So let me just show you what that looks like. So instead of our maximum being 0.05, our maximum is going to be the blind width. We'll just say, we'll actually use this variable now. So let's say the 0.10. And so the max, let me rename that just so it sounds better. Max blind width is now 0.10. So if I put max blind width here, it creates the illusion of the blinds staying closed, but what's happening is it's just overshooting. And it's closing and opening way too quickly. So let's modify the speed of this. To modify the speed of it, we're going to stretch out the period of the graph. So we modify the x value, which is the u time. Let's say 0.2. See what that looks like. All right, well, that looks better. Stay closed and open on me. Open. Is it going to open? Open. Maybe 2's too slow. Let's go 4. See what that looks like. 4. And open. All right. We can always speed it up, but we've modified the time it takes to open and close the blind. Let's solve the problem of the blinds they're the wrong way. We need to rotate them in the space, in the 2D space. So we're going to use that little function here, this rotate 2D. So we're going to say, when we create the blinds, the value we're seeding in right here, we need to flip that value, rotate it in 2D space. So we're going to say st is equal to rotate 2D by pi, which is half of 2 pi, which is half of a circle, which is 180 degrees, and multiply that by st. So what's happening here? Where did our blinds go? Well, let's go into... Let me just fix it first, and then I'll explain what the fix is. st.y minus equal 1.0, and we have our blinds fixed. Now it's closing, or it's showing up the way we want. It's starting on the top, closing towards the bottom, and then going back up. All right. So what's happening? What do these 2 lines mean? Let's draw it in space. So what we have is we have our canvas, and our canvas exists in a 2D coordinate plane. And everything we see on that canvas is in quadrant 1. You could think of it like that, like this. Down there, perfect. So quadrant 1 is this quadrant here. We call this quadrant 2, like that. This is quadrant 3, like that. And this is quadrant 4. So when we rotate the canvas using that rotate function, we're rotating it by pi. Pi is half of a circle. Pi is equal to 180 degrees. Basically, we're just flipping it. And so right now we have on our canvas, before we flipped it, we had that left curtain, we had the horizon, we had all the blinds here, and we just saw it right here. When we applied that rotation, it rotated it down here, which is 180, 180, 180, 180. This would go down here. Yeah, rotated it down here. So we had the blinds here, and then we had the horizon here, or excuse me, the curtain here, horizon here, blinds here. What we need to do is we need to take this final product, we need to move it up into the first quadrant. That's why we did the shift first. So when we shifted with this line here, 41, what we said is all the y values, shift them up. I know it's kind of counterintuitive. We say minus, but that actually means go up. So when we say minus, we say shift all of those y values, the whole graph, essentially. Shift the whole graph up by 1.0. So what we have is, we have the graph shifted up here. Can I do this? Let me shrink the thing just a bit. There we go. So we have the whole graph up here. So let me just go step by step in the code and you'll see it. And then the blinds up here. So if I take off the rotate, we still don't have the blinds. That's because the blind, the whole image is out of the viewport right here. So we said shift all the blinds by negative 1.0. So we shifted it up and then flip this guy down here. So then we see in our viewport, left curtain, horizon here to match this horizon here, and then the blinds going down here. So now when we say rotate 180, we get the effect here. Sorry, just to clarify, why aren't the curtain and the blinds, why aren't this horizon right here, why isn't that also flipping? Well, we're only applying this transformation, this negative 1.0 plus rotate 180 degrees. We're only applying it to the blinds. Because we manipulate the 2D space before we write all that code for the blinds, it only applies to the blinds. So anyways, we fixed the problem we were having, where the blinds were opening on the bottom first, then closing at the top. Now they're opening on the top first, closing on the bottom. Let's animate the background and see what we get. And we get basically what we want. Let's smooth out this picture, and we should be done. How do we smooth out lines? Well, we use smooth step. So we can convert some of these steps into smooth step. Let's smooth step the curtain first. So instead of step, we're just going to say smooth step, and we're going to go from 0.2. Let's go to 0.255. Let's see what that looks like. It's a bit too harsh. Let's go, I don't know, 3.3. There we go. That looks a bit better. Let's do the same blur effect for the horizon. So smooth step and 0.2 to 0.233, and we get that blur. And then let's blur the lines for the blinds. We don't want to blur where the blind is hooked into. We just want where the blind is moving. So we don't want. So the blind is here. Blind's here. We don't want to blur where it's hanging onto the window. We just want to blur where it's moving. And so that's the second step of the difference equation we had, which is up here. So this guy has to be converted into a smooth step. So smooth step, start position plus blind width. And now we want the edge, second edge case to be start position plus blind width. Blind width, there we go. Plus that, let's say, I don't know, what was it, 0.3? Let's say let's try 0.2, see what we get. Nope, 0.02. There we go, it looks better. And do we get, how does this look? It's still closing for far too long. Let's change that. Where's that max blind width? Let's just say 0.58. That's right. Actually, it has to be above 10. And something's still not right about this. It's closing for far too long. I see what's going on. I missed a part of this. All right, so you know how we flipped the sky it was red on the top and we wanted red on the bottom, so we inverted that relationship. We need to do that with the blinds because right now it's staying closed for far too long and it's opening for far too short. You want to reverse that. You want to open for longer and then close for shorter a bit. So instead of the 1 minus that st.y here in order to reverse the relationship, we're going to go max blind width minus, see what we get. Say close, go open, and close. Perfect. Let's speed up the blind speed right here. Let's go, no, 2 would be too slow. Let's go 8. Let's see what we get. Nah, it's too fast. Anyway, so you can play around these values, modify the look. Let's just, for now, let's take this out so we can see. Let's say blind speed like this. Speed. Blind. So that's going to be it for the video. I'm just making it 3. So we went over like how to use step and how to use mix in order to create this little canvas here. This video was interesting at all. If it helped you at all, don't forget to like, share, comments down below, subscribe if you haven't already subscribed. And why is this not working? See you guys in the next video.